So I'm Noah, you already know that. And this is 10 must-know concepts in machine learning. So a little about me. I'm a data science and machine learning consultant. I've been working with data for roughly a decade, both in the academia and in the tech industry. In my time in the industry, I worked mostly in the risk and cybersecurity domains. I worked for PayPal, for Armis. I also consulted to startups a little bit about fraud detection and how to mitigate the risk. Today, as I said, I'm a consultant. I work mostly with companies that don't have their own data science in-house teams. And I also, in my spare time, take part in the Open Knesset project for transparency in the Israeli parliament. And I lead the Israeli community of women in data science. Some of you should be from there. Okay, so 10 must-know concepts in machine learning. First of all, why? Like, why should that interest you? I mean, either you're data scientists already, and then you know them, or you're not, and that's just not what you do. So why would you need to learn it? So as you probably know, data science is becoming very prominent in today's tech industry. It's hard to work in tech and not always be bombarded with data science and machine learning terms. And basically what I want for you is that even if it's not your major occupation, then that you'd be able to participate in a conversation that has something to do with it. Because I assume that all of you here has sat at least through 1 or 2 meetings where all that machine learning jargon was thrown around and you just like smiled and nodded. So if I do my job right here, at the end of this talk, you'll be able to not only smile and nod, but also actually understand what people are talking about and even give your own input. So the concepts here, the 10 must-know concepts, are all they weren't chosen by me. When I built this talk, I posted in the Baot Facebook group, I posted a question of those of you who are not data scientists, what are those terms, those concepts that you always hear around you and you don't know what they mean and you want to know what they mean? So all the concepts that I present here are ones that you asked about. So if you don't like them, that's on you. Okay, machine learning model. That's a big one. So what's the definition of a machine learning model? A machine learning model is a mathematical model that uses simple data in order to make predictions or decisions without being explicitly told how to solve that task. So I assume that's clear now? No, I'm joking. I'm not that bad teacher. Let's go through an example. So say I have a friend and she teaches piano. And she's not just any piano teacher. She teaches piano to cats. And not only does she teach piano to cats, she teaches cats to play Beethoven on the piano. It's a very specific niche. And that friend is she came to me and she asked me if I could build her a model that could predict if a cat could or couldn't play Beethoven on the piano. So basically the machine learning model here would be a model that would take as input data about each specific cat and would make a prediction as an output whether this cat could or couldn't learn to play Beethoven on the piano. That's the machine learning part, because the model, it's a machine and it learns. Like the whole point is that I don't tell it how to do it. I just give it the data and it learns by itself. It's very cool. Okay, second term is examples or samples. So basically, data scientists, we're pretty bad people. And for some reason, we keep taking terms and words that have other meanings in the world and just use them for whatever meaning we want to see people get confused. I don't know. So examples in the machine learning world is their data points. So in our example, in our scenario, see, it's so confusing. In our scenario, examples would be cats. So each cat is a data point. Each cat is an example or a sample. It's the same thing. Features, again, sorry, software developers, we mean something completely different. So features are representations of data. Basically, the features are how we represent the data about the cats to the models. So let's look. So for example, a feature could be whether a specific cat can play another instrument, or whether this cat has an affinity to wearing really stupid hats. Those are two features that we could present to the model as data, as information about that cat. So this is an example for a data set. When we actually put the data into the model, we, of course, need to be structured. So here we can see a data set with three examples, 3 data points of 3 cats, and we have different features. We have, in this scenario, the age of each cat. We have whether it likes hats, whether it plays the guitar. We have the color, and the model can look at all of those features and then learn patterns. Label. So the label is the output. The label is basically what we ask the model to predict for us. Now, this is going to be the first interactive part of the talk. I know that it's harder when it's an online talk, but I'll ask you to write it in the chat. Please, no data scientists answering. Those of you who are not data scientists, if label is what we ask the model to predict, what would a label be in our scenario? Yes, all right. So the label will be whether the cat can or can't play the piano. So way to go, those of you who answered. All right. If we look at the same data set from before, this is what it would look like if I add a label. For each cat, for each sample, I'll also tell, at the beginning, I also tell the model what the label is, whether this cat can or can't play the piano. And that's how the model learns. Okay, training and testing. Those are 2 phases that I have when I build the model. Let's go through them. Okay, so first training. I have the model. It's not smart yet. It hasn't learned. It's a machine, but it hasn't learned yet. Learning is important. So I go to my teacher friend and I ask her, could you give me some data about your past students and whether they could or couldn't play the piano, which one of them? And then she's like, yes, here's all my data. And I'm like, no. I don't need all your data. Please hold out like maybe 20% of the data and give me like just the rest. And he's like, you have weird requests, but okay. And then I take that data and I put it into the model. And I give the model everything that I know about them, the way that I showed you before, both the features and the label. And then the model learns, that's the training phase. Basically, the model learns by itself the patterns from the data. And then I have the testing phase, which is when I have the model and I know it's smart, or at least I know that it thinks it's smart, but how can I tell whether it really does its job right? I mean, it could be really bad judge of whether cats can or can't play the piano. Not everybody can do that. It's a very hard task. So that's when I go back to my teacher friend and I tell her, remember that 20% that I asked you to keep, like, of the data, I'd like to have it now. And she's like, sure, I kind of wanted to give it to you in the first place, but take it now. And then I take that data and I hold the label out. I know that for that data, I know for each kitten whether it could or couldn't play the piano, but I don't want the model to see that. So I give it to the model and I ask the model to predict, and I don't tell the model what the real label is, and I ask it whether those cats could play the piano, and I see what it says, and then I compare it to the true result, the true label. It's what we sometimes call the ground truth. and then I can measure how good that model is. Okay, so a quick recap of everything we went through so far. Machine learning model is a model that takes data and then learns by itself how to do the task that we ask it to do. Examples or samples are data points. In our scenario, it's kittens. The features are representations of the data. For example, how old that cat is or what color it is. We have the label, which is what we ask the model to predict. And we have the training phase where the model gets data with labels and learns everything. And the testing phase where I check to see if the model actually knows its job. Okay, so I have a confession to make. I kind of cheated. Everything that I told you so far was just supervised machine learning. And while we have supervised machine learning, and it's a big part of machine learning, we also have some other parts, for example, unsupervised machine learning, which I'll go into in a minute. So basically, the difference between supervised and unsupervised machine learning is whether we have a label. It might not be so clear right now, but I promise it will all be clearer until we get to the end of this talk. So for supervised, as we said, we have the label, we have a classification, and we have regression. What's the difference? The difference is just if the label is categorical or numeric. If it's categorical, if I ask the model to take each example and assign it to a group, to a category, then it's classification. Basically, I use classes. I ask the model to assign each example to a class. But maybe I want the model to do something different. Maybe I want it to predict a numeric label, for example, housing prices, or the number of people that will have COVID-19 in the world in 2 weeks. I don't know if a regressor could do that very well right now. So in that case, that would be a regression task. And a regressor is what we call the model that does that task. So here's a little game. Again, I'm gonna need you to be interactive. So be ready with your keyboards. Let's see if it works this time. All right, so classification or regression. Let's take the scenario that we talked about. We have kittens. We want to know whether they'd be able to learn to play Beethoven on the piano. Would that be classification or regression? Yes, all right, it's classification. You are very good. All right, but say that my teacher friend has another task in mind. She wants to know how many days it's gonna take that specific kitten to learn to play Beethoven. Say she wants to know, I don't know, how many hours. Yes, regression, you're very good. Another task. She already knows that each kitten can learn the piano, and she wants to know how long the longest musical piece that they could learn is. Yes, it's also regression. Way to go, you've been listening. Okay, a different task. She wants to know what compositor, what musical compositor each kitten would like best. We have Mozart, we have Beethoven, we have Bach. Yes, it's classification. All right, I'm very happy with you. Way to go. Okay, so that was supervised machine learning. We also have unsupervised machine learning. It's a bit less intuitive, but we'll go through a couple of examples. There are many types of unsupervised machine learning. We'll talk about clustering and anomaly detection. So clustering. Clustering is going to have a data set. Let's take an example data set. Now, I want you all to know that I did not have to make this specific picture. It's out there on the internet. So say I have this data set of kittens, and I want to see what groups it holds. I don't know the groups in advance, and I want to see what groups or clusters exist naturally in the data. So in that case, I take a clustering model, and I ask it to assign, to create those groups for me, where each group has the examples that are most similar to each other. So it might look like that. That would be a clustering algorithm, clustering model. Anomaly detection, it's something very different. So maybe I work for a security company. It has been known to happen in the past. And maybe I monitor traffic data of computers, and I want to spot the ones that are hacked. I know that some are going to be hacked, and I don't know what it's going to look like, but I know that it's going to look different than the other computers. So in that case, I can ask the model to just point out those specific examples that are very different than the other ones. In that case, that would be the computers that behave very differently than the rest. So maybe it would be those. The model would look at the data and say, hey, like, here are a few that are not specifically, they don't act exactly like the other ones. You might want to check them out. Now, I want to go just pause for a second, because we talked about classification and we talked about clustering. And a lot of people kind of have trouble understanding what the difference is. And I want to make sure that you understood it. So again, I'm going to go to the chat. And do you understand what the difference between classification and clustering is? What would you say the difference is? Thanks, internet. Nice. Okay, yes. Okay, it's supervised or not, yes. And in other words, we could say that the difference between classification and clustering is whether we have a label, and more specifically, if I have the predefined groups. So in classification, I already have the groups, I have the classes. I'm the one telling the model what the classes are. And I ask the model to assign each example to a class that I defined by the label that I give it. With clustering, I don't know what the groups are. It's not only that I don't give the model the label, which is a very, very important part. I also ask it to tell me what the clusters, what the groups are. Okay, so those are basically 10 terms, but I feel you've been very good answering all of my questions and everything. And I could give you another bonus concept. Okay, I lied, it's 3. So when I asked in the Facebook group, when I asked everyone, including you, when I posted at first, when I was building my lecture, and I asked you what concepts you'd like to learn about, then my favorite question was, what's AI? What's ML? What's DL? Why do you always hear about it? What's the difference between them? What do they have in common? Could you please just make sense of it? And I actually think it's a very important question because those terms are thrown around a lot, and it is important to understand what they mean. So let's start from AI. AI is artificial intelligence. It's a very, very broad term that basically can describe any piece of code that does anything smart. There isn't really a very good definition for it. It's mostly used when you're trying to market something. It was used a lot before machine learning became very prominent. And also sometimes when people hear about AI, they think about robots that have feelings, which are adorable, but are not what we usually mean when we say AI. Then we have machine learning. It's a machine that learns. There's a model. It's smart. It can do things. It's basically what we talked about this whole past 30 minutes. So if you don't know what that is right now, I did a very bad job. And then we have deep learning. So deep learning is a bit of a complex subject, and it's a bit out of scope. Sorry, deep learning is a bit out of scope right now for our talk, but I do want to just go a little bit into it because it is a term that's used a lot, and I think that it's important that you know what it is. So basically, when we say deep learning, we're talking about a subclass of machine learning algorithms that are based on artificial neural networks. Artificial neural networks is a class of algorithms that are called that way because they're based on models of how our brain works. They basically simulate our brain. And deep learning is based on that concept. It's a method that's very computationally expensive, requires a lot of data, a lot of work, a lot of resources, but it achieves some amazing results. So it usually won't be the first thing you should try when you tackle a new problem, unless you're in some specific field where deep learning is the more common use, like computer vision. But when you do use it, it can get some pretty amazing results. Okay, so a quick recap of everything we went through. We talked about a machine learning model, which is a machine that learns. You give it data, it figures out patterns, it learns by itself how to do a task without being told explicitly by us. Examples are samples, which are data points that we give to the model. Features are representations of data. It's how we present the information about each sample to the model. The label in supervised machine learning is what we ask the model to predict for us. Training is the phase in model development where I give the model the data and I let it learn patterns and basically train itself in solving the task that I asked it to solve. Testing is when I already have the model and I want to try and see if it knows what it does at all. So I take some of the data I have and I hold out a label and ask it to predict, and then I compare it. We have supervised machine learning and we have unsupervised machine learning. Supervised is when I have a predefined label, and unsupervised is when I don't. Classification and regression are both supervised machine learning tasks, and classification is when the label is categorical, when basically what I asked the model to do is to assign each sample to a class. And regression is when the label is numeric, when I ask the model to predict a specific number, a continuous number for me. We have clustering and anomaly detection, which are both unsupervised machine learning algorithms. So clustering is when I have the data set and I ask the model to find the groups that are similar within that data set and tell me what they are and where each sample goes. Anomaly detection is when all I care about is those specific samples that behave differently than the rest of the data set. And we have AI, ML, and DL. AI, artificial intelligence, not robots with feelings, but a broad term that applies to both machine learning and anything that's like smart. Machine learning is what we talked about here, and deep learning, a specific subclass of machine learning algorithms that are based on artificial neural networks and do amazing stuff, but at a high price. Okay, you are now all data scientists. Happy? I am, of course, joking. You are not data scientists yet, but I do hope that the next time that you sit in a meeting where some data science aspects and machine learning aspects are being discussed, or the next time that a project you do at work also has something to do with machine learning, that you'll be able to understand it better and provide your own input and understand what's happening, so you could perform better as the amazing tech professionals you are. And that's all. That was me. If you'd like to keep updated, oh, thank you, thank you.
Thank you very much.
If you'd like to keep updated on talks I give and blog posts that I write, which is something that I do, then you can find me on basically every social media platform out there. And do you have any questions? You can ask them on voice right now, but you can also ask them in chat if you want to. Will I have more lectures about it? I wasn't planning to, but if you want to, you can ask me, just tell me what you're interested in, and I might do it. Basically, I do whatever Corinne Bell tells me to do, so if she tells me to give a sequel, I'll do that. All right. You can also like Facebook me or email me and tell me what you're interested. Okay. Thank you.